Abby, is this Hangout is live on air? I need to check if everybody is online watching me, or am I just talking to myself? Either way. Either way, hopefully this is working. Is this working? Okay. Is this working? Is this working? I see my voice working, so I'm hoping that this is up and running. If at all possible, I'd like everyone to join this who can. You can all go to the class website, join it, and join the chat and add the chat to the conversation or the box, so that you can chat with me and ask me questions and let me know if you can actually hear me. Are we online live? I need someone to tell me. I'm just gonna click here, send to mail. I didn't send anything to her. Thanks. Oops. Compose. Come on, computer. Computer, I think I forgot. Hey, computer. Boom. I'd like to know if this is working. If you've joined up, you can join and watch me and someone chat with me and tell me that this is working. Or Mrs. Kim, you can phone me and let me know that this is working. Because right now I'm talking in the dark. I don't know if this is actually working or not. I don't know if you are actually following me or not. Yeah, let's go to the live feed. The live feed is a few seconds behind me, but I don't know if you're watching me or not. So if you are in class, I need you to go to the link from like the class website, dez.kkfscs.com, and click on that link to join the broadcast, to join the Hangout. If you join the Hangout, then you can chat with me. All right. I've got one viewer, and that viewer is myself. Sent mail. Give me a call, Miss Kim, if you can, and then we can see if this is actually working to get this up and running. Someone in class can help out on this computer, my computer, teacher's computer, get things up and running. Should be working, because I can click on it. It should be broadcasting live. You should be able to click on the button that it goes to and then just click play and watch. I know the video quality is not that great, but it should be working. Quality is not important in this case for the video. All right, got a video coming through. Ooh, phone call. Hello. So it's working. All right. Has the bell rung yet? Okay. So I'm just going to start teaching then. And if they... Yes, this is a weird experience because I'm talking to no one basically, but it worked last class, so all right. So I'll just start teaching now. Thank you. All right, welcome. First off, I'll mention this again. Well, I'll mention this the first time. While I'm talking, while I'm explaining how things are going to go today, you should all log into your App Inventor site on Google. Sorry, just your App Inventor site. Get that working in there so we don't have to waste time later on with signing in. So your computer should be on. You should be signed into your account. If anyone is missing today, other than myself, if anyone's missing today, Brian, you can go take their seat so you can have a partner. And that will take care of that. If not, Brian, when it comes time to talking to an elbow partner, you can just turn around and talk to Romario and his partner, okay? So that will be your three, okay? Thank you very much for that. So first off, let me explain what's happening today. Last night, my daughter got down sick with a really high fever. It was like over 40, which is really high. So she went to the hospital, got medication, doing much better today, but as a precautionary thing, the doctor was like, keep her home tomorrow. So that's what I'm doing. So thank you for understanding for that. She's better. She's still alive. And the medication is making her feel like she's wonderful, even though she's really sick. The beauty of medicine. All right. This is going to be an experience for both of us. Last class, 4th period, we got it done. We did it, and it seemed to go okay. You can so be expecting of this might crash halfway through or something might happen. Please bear with me. This is kind of like an experiment. Just see how this goes. We should be able to do the lesson. We did it last class. We got through everything we need to get through, and thank you for being understanding of the current situation and chalk it up to a learning experience for all of us. And I don't know, maybe we can think about, discuss later on, is this the way education is going to go? Would you appreciate this kind of situation where if you were hanging out at home and you had some bald white guy, well, I guess on the screen I look kind of pink, bald pink guy talking to you, drinking water from a cup, teaching you. So we can discuss that. Is this the future of education? Who knows? I don't kind of like it because I can't see your faces and I have no idea who you are or anything like that. It's very weird from this situation, my situation, because you guys don't have a mic and there's no camera, so I literally have no idea what it sounds like or looks like in the classroom. But that's okay. We can get through this. All right, so that being said, thank you very much, and let's get to it. We have an hour and 25 minutes left. Sounds like a lot of time, but we're going to have so much to do. Overall today, here's a plan of what we're going to do. We're going to review if-then decision structures, because we haven't done that in a while. We've been spending a lot of time on abstraction, at least stop moaning. We are going to return to if-then decision structures, review that for a bit. We're also going to keep hitting the abstraction. I know it's hard to get locked in your head, but we have to do it. The more times we do it, the easier it gets. If you remember at the beginning of the year, I said you're going to be introduced to new concepts at the beginning of the year, and some of them are going to be hard to get in there and get stuck into your brain. But we're going to return to these concepts all year. So, of course, it's going to be a little frustrating at the beginning, but by the time we get to the end of the year, you should be good to go, and it should make a lot more sense. We're just going to constantly return to this idea of abstraction and look for examples of it in our programming and in everyday life, and so that eventually you'll get it. And so this is part of the process of learning what it is, and me constantly asking you, how is this an example of abstraction? Please give me an example of abstraction now. Okay, and we're going to do that again today. Okay, once we have done a review of abstraction and our review of if-then decisions, we're finally going to get back into App Inventor, and we're going to start adding some components and reworking or making PaintPot even better. Right now, PaintPot's fun to play with, but there are some limitations to it, such as changing the size of the dot size that the user paints with. We're going to add more functionality to our app in terms of passing on the control of the dot size from you, the programmer, to the user. So the user, as they're using the app, are going to be able to change the size of the dot in real time, bigger or smaller. So that'll be an example of abstraction, and it'll be an example of making a program more user-friendly in terms of enjoyment and putting more power in the hands of the person using the app. Okay, and we'll program that, and we'll talk about, while we're programming that, bugs that are going to come up in our program and how we're programming it, and all the sorts of lovely little mistakes that are going to crop up or thinking about abstraction during our programming. So the first thing we're going to hit up today, as I mentioned, is dealing with the concept of if-then decisions. Okay, it's a basic concept of computer programming and computer science, and it's something that you're going to be using in every program until we finish the end of the year. If you think to our first app that we made, the I Have a Dream app with the Martin Luther King and the Malcolm X app, where the user clicked on the button and it played the sound. We have this basic idea of cause, effect. Get my hands on the screen there. Cause, effect. I do one thing here, and as a result of that one thing, if this event happens, a result is occurred inside the computer. Some kind of clicking here produces this. So we've got this, if this happens with big hand. If this happens, then do this, okay? So if they push the button, sound will come out. Everyday life. If it's snowing outside, cancel school. Miss Kim, that's a message for you. If it's snowing outside, cancel school. Okay? If I'm hungry, eat. If I'm tired, sleep. Okay? These basic, simple things that you do all the time in life, computers don't do them. Okay? It may look like they're programmed to do a decision, but you, the programmer, are the one doing that decision-making process. To the user, they don't care. Okay? They literally don't care, and they shouldn't care about the actual programming inside of how that is happening. They just see it as, oh, look, the computer's doing something. You, as the programmer, you have figured that out. You've abstracted all the important details and gone down to the little nitty-gritty details and figured out how to make that program do that. Okay? So what I'm going to do is I'm going to look, let's broadcast a screen from I Have a Dream so we can look at some examples. Okay, I Have a Dream coming up here. I'll zoom into the app. Okay, so remember with our view blocks, we had the if, then, else blocks in our program. We had the idea that if the Malcolm player button is clicked, go in and do this decision structure. If MLK button is playing, if this is true, this little block here, if this comparison here, or this fact that we put in here, if that is true, then it's going to do this. Okay, so this idea, if this here, whatever we put here, if this is true, then whatever I put here, this will happen. However, if whatever I've put in here is not true, go down and do whatever else I tell you to do. So if this is true, do it. If it's not true, do this, okay? So we had this idea in the MLK, if MLK was playing, then tell him to stop. Tell him to pause. If he wasn't playing, then start it and make the phone vibrate for 1 second. Okay, so we got a direct, it looks like the computer is doing a decision really quickly. Oh, if I've clicked it, that means, and it's playing, I want you to stop. If it hasn't been playing, oh, that means I want you to start. Okay, that happens in a millisecond. It looks like your game, or your app, I should say, is just thinking its way through it, but no, you, the programmer, you have to figure that all out. Okay, and of course, these blocks are found in the in the control section of our built-in blocks. And when we want to add more else's, we just click on that blue little, this is called a modifier, and you click and you drag in the else. Okay, so now we have an if then else, so we got more decisions. Okay, and we could have more than one. We could have if then else, if then else, so many options. There is no limit to how many we can stick in there. Oh my goodness, doesn't that look scary? Let's just do it again. Oh, don't worry, we don't have to deal with that many. Okay, what I want you to do now, okay, is I'm going to give you 30 seconds of some thinking time, and I want you to think of 3 real-world examples, so examples from your everyday life, 3 of them. That's 1, 2, 3. 3 examples of everyday decisions that you made today. So since the time you woke up this morning till this exact moment, I want you to think of 3 examples that you have done, okay, that can be seen as examples of if-then decisions. Okay, I want you to explain it in terms of an if-then decision. So, for example, here's my example. This was last night. Last night, my daughter was sick. So, when I was figuring out what I'm going to do for today, I said, okay, I told myself, if I wake up in the morning and I check Mina's temperature and she still has a fever, if that is true, so if Mina, fever, yes, okay, what am I going to do? Then I'm going to email school and tell school, sorry, I have to look after Mina today, okay? Otherwise, go to school, regular day, okay? So obviously we know what happened because I'm here and you're there, okay? So it was true. I woke up, checked Mina's temperature in the morning, and she was running a fever still, so sorry, I'm not there today. So that's an example of describing an everyday decision that I made in the terms of App Inventor block. So if something was happening, then do this, okay? So that's what I want you to do. I want you to think of 3, 1, 2, 3, okay, examples today, from you today, that you can think of that would be great examples for that. You're going to think of those for 30 seconds, and then you're going to turn to your elbow partner, and you're going to explain those examples to your partner. Okay, so Brian, if you don't have a partner, you'll be with Romario behind you, okay? The 3 of you guys, GA, you guys will be a triangle, okay? So you're going to think of 3 examples, everyday examples from today that you can explain in terms of if-then. Please take it seriously. Don't give like a silly example, right? Think of like a meaningful example that would to help the other people around you. And then once you're finished with your 3 examples, you'll switch and it'll be B's turn. Okay, so I'll give you, starting now, I'll give you 30 seconds of thinking time. Just thinking of your examples. 30 seconds starts now. All right, that's 30 seconds. A's, turn to B's. Go ahead, start talking. Give your answer. right, if you haven't switched by now, switch it up. All right, time is up. Up is the time. I want you to look at your elbow partners, and I want you to give your elbow partner a high five. And as you give them a high five, don't give them a high five yet. As you give them a high five, you're going to tell them, you're going to look them in the face, and you're going to tell them, your brilliance is melting my face off, and then give them a high five. Alrighty? Right? So here we go. 3, 2, 1, high five. Boom. Your brilliance is melting my face off. Yes. They're so brilliant like the sun. All right. So normally at this point, I would like us to share some examples with each other, but being the situation that we're in, that can't happen. But hopefully you came up with some brilliant ideas. I know you did. I know Eric has an amazing one that he'll share with us tomorrow. So Eric, tomorrow. All right. All right. So next we got to talk about the wonderful world of abstraction. Okay, and as I said, I know it's hard to get your head around sometimes, but we're going to get it. Don't worry. We're going to get it. So what is the one word, Romario? What's the one word we can think of for abstraction? How can we take abstraction, the whole concept of abstraction, don't interrupt, and bring it down to one word? Starts with an S. It is simplify. Okay, simplify. So any idea that we have, any concept we have, we can abstract it down into a simple idea or a more complex idea. Okay, we've been looking at this a lot this last week because just like the sorry, my nose is really itchy, sorry. Okay, just like the decision structure is a fundamental idea in computer programming, the if-then. Another fundamental concept you have to understand when you're doing computers is the idea of abstraction. In programming, they're always trying to make programs as more abstract as possible, more general, and when computer programs are done in this way, they're much more robust. That means it's harder for them to crash. They can deal with all sorts of situations. When a program is not very abstract, it can only basically do one thing, okay? And we'll have some great examples today. It'll really start to make sense today, I hope, with the program we're going to, or the things we'll add to our program today will kind of make it go, oh, okay, I get it now, okay? Hopefully, we'll get there. Okay, so remember this concept of abstraction is the idea of taking an idea up here above your head, right here, taking this idea, okay, it's a big idea, or a problem, a concept, and breaking it down into simpler parts. Okay, if you think of math class, you're doing that every single math class. You're given a problem, a word problem, and then to solve that problem, you break it down into little tiny parts, okay? And together, all those little parts together solve the one problem up top. So you're abstracting down to the different levels of the problem, okay? So for example, if you have a, I don't know, your basic algebra problem where it's like A equals something divided by something, square root, blah, 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 right? When the teacher says simplify your answer, what they're really saying is abstract your answer. Get the little parts down that you need to solve to get the whole idea. So you got the big idea, okay? Then we'll go down to the little tiny details. How do we solve the first part of my problem? Okay, once I figure out how to solve for X, and then okay, so that's how you get X. Okay, my problem also has a y, and how do I figure out y? So you go over and then you abstract down to find the information for y. Okay, so whatever problem you have, you can break it apart into the important parts that you need, and then you can start to solve it. This is really weird with the hands. Okay, you can start to solve it going down this chain of getting more and more detail so that eventually you're at the lowest level of abstraction down here where you're really fine detail. But when you move back up, when you start putting all those little fine details together, we get a bigger picture and we can work at different levels. And it's the same idea with our programs, okay? We want to first think up here in our programs of how to solve that general idea. It's like, oh, I want to make a program that does this. So it's a general idea. And then you have to start thinking about the specific parts to solve that program, okay? Well, I want a program that does this. How do I do that? Well, I need this component, okay? I have this component. What do I have to do with this component? Well, I have to set the properties of this component to be this, this, and this. Okay, so then you set your properties. We got the little finer details. And then with that component, I have to have an event, some kind of event handler. So I get more details. And then I get down to the actual programming of that event, okay? And we've done exactly this in our what's it called, the Paint Pot program. Okay, we've done that in this. We have a red button. So the user, when the user is using this program, the user is just clicking on the red button. They don't care what happens on the inside in terms of the inside of the blocks. They don't care how all this happens. All they care about is the user is working on this level, a really high level, or sorry, high abstraction, where all they know is that I click the red button, I can draw on the face of the cat. I click the green button and I can draw green lines on the face of the cat. Okay, that's all they care about. So they're really high up in abstraction. They don't really care what's going on. Okay, they just know button, push, draw, giggle, hee 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 hee. Okay, you as the programmer, you have to think, okay, I've got a red button. Well, right there, there's some abstraction. I've got a thing, I've got a component, I've got a red button. So I've got to add a red button to my list of components. So you add that in. And then you think, okay, how do I program that? And then you start thinking of the actual event that happens with your program. You go into your blocks and you brought out the red button click event block, and you set that up so that when the red button is clicked, what happens? Well, you put in the set canvas paint color to red. So you've got really fine details down to the exact color. The user isn't thinking like that. They're not thinking, well, this is an event handler for the red button, and when you click on this button, it will change the canvas color to red and allow you to paint. No, they're just thinking red button, click. But you as the programmer, you have to first think of the big idea, the big problem up here. Red button, click. Okay? And then you got to think down, how am I going to do that? How am I going to accomplish that? So that's a fundamental part of computer science, is that people ask programmers, make me a program that does this. And you're like, okay, I'll try. Okay, so they give you a big idea of, I want an app that'll allow me to blah, blah. And then you as the programmer, you take that big idea and then you break it down into the small little parts. Well, your app wants to do this, so it wants to do this. How do I do this? And then you break it down into its small parts. You abstract down. Okay, my app also has to do this, so I'm going to have this idea. How do I do this? Well, you add this and this and this and this and this, and then slowly over time you have kind of like this big tree or this big triangle of, you have this idea, and as we go down in abstraction we get more and more details. We're abstracting down to the finer details, and every part of our level we're dealing with abstraction. Either we're going up or down. We're removing information when we think general. I have a button that I click. Or we're going down in abstraction. I have an event handler that when it's clicked changes the canvas's color. This is a really important concept because in programming, all of this should be done on paper or in your brain or like planned out before you actually start making your app. Just like when Miss Boyd or Mr. Brennan tells you before you write an essay to write out an outline on a piece of paper, sketch out what you're going to do. Same thing should happen in programming. You think of the idea or the problem first, and then you think about how you're going to attack that. You make a plan. You get as detailed as you can in your plan. And as you're doing that, you're thinking about the problems. You're working out the problems in your mind before you make the program. Okay? So you abstract from the major problem. You figure out what information do you need to know, and then you slowly attack different parts of the program. You abstract down to solve the problem. Okay, enough of my pink head talking. Okay, hopefully again, we'll get this problem again, and I'll ask you again and again and again. Simplification, abstraction. We're simplifying information. We're getting our nitty-gritty detail. We're simplifying it to the big ideas. Okay, and when we concentrate on the big idea, we get better programs. All right, we have, ooh, you've got 1 hour left of class. Ooh, 1 hour. Okay, so what we're going to do now is one more time, and this should be relatively simple because your homework that you did last class or last week on the last app was to write down 3 examples of abstraction from our program. I just went in great detail about the red button. Okay, I want you to think about one more, and that's okay if it's the same one that you talked about last week, okay, or wrote about last week for your homework, typed about. Okay, I want you to think about that one more example of abstraction. Okay, and I want you to share that with your partner. This time, the other partner is going to go first, so B goes first. And once you're switched up explaining the abstraction, A will go. Okay, so I'll give you 30 seconds to think about your answer, think about your abstraction. After 30 seconds, when I say go, B, start a talkity talk talk. All right, 30 seconds starts now. All right, that's your think time. A's, go ahead. Oh, sorry, B's, go ahead, talk. If you haven't done so yet, switch over. A, it's your turn. I'm gonna pull a little. I'm gonna do a little Mr. Brennan right now, and I'm gonna burn some incense. All right, time is up. Up is the time. Here's what you're going to do. You're going to look at your elbow partner. You're going to give them a high five again. And this time, very simply, you're going to give them a high five, and I want you to say, thank you for being a great partner. Go ahead, 3, 2, 1. Thank you for being a good partner. Why are we doing it this way? Because this is the last day you're working with your partner. Yes. Tomorrow you're going to be getting new seats. Bum, bum, bum. Yeah. Yes, tomorrow you will be getting them today, but I'm not there. So tomorrow you'll get your new seats with a new partner. Oh no. Yes, yes. You've been with your partners for 8 weeks now, or 7 weeks. That's more than enough time to get to know each other. Don't worry, all your programs are online, so it doesn't matter what computer you go to. It's all online, and it's another opportunity to get to know someone in class. Okay. Normally, right now, we would talk about your examples of abstraction, but again, I'm not there, so it can't be done. I apologize. But Eric, tomorrow, I'll ask you too. So that's 2 things, Eric. It's tough. All right. So now that I've confused you enough again with abstraction, it's time to start building some apps. Let's do it. So as I mentioned before, you should be logged into your App Inventor, and you should be JJ's handphone didn't work and had to find another computer. Sorry, I'm just reading a message. Then the computer browser didn't work and he borrowed Romario's headphone to listen. You will be okay, very interesting. Thank you. Lost my track of thought. Oh yeah. Okay, so get yourself into the inventor of the app, or App Inventor. I'm gonna go over to screencasting now. Okay, I'll zoom into the app a bit more, and this is what we're going to be doing today. We're going to be, as I mentioned, we're going to be adding some usability to our app. As you can see down here, you should notice right away that we have some changes to our interface, okay? We have it so that there is a minus button and a plus button on the user interface. And in the middle, it tells us the size of the dot that the user has currently chosen. So right now, our dot size, the default is at 5. We want to change this so that when the user clicks on the plus symbol, it should go up to 6, and then our dot on the canvas will actually change. And vice versa. If we keep hitting minus, our dot size will get smaller. Okay, so I'm going to give you a few moments now, and what I would like you to do is I would like you to add the appropriate components to the user interface that you see here. Okay, so we got some buttons, we've got a label, and don't forget to change the appropriate properties for each one of these buttons. Oh, sorry, for each one of these components, okay? So add these components that you see here, add them to it, and I'll give you a few moments to do that, and then I'll come back and I'll show you how it should be done, okay? So I'll give you 2 minutes to do that. Is that annoying yet? While you're doing that, I'm quickly going to go to the other room and see if Mina's still alive, because it suddenly got very quiet in the other room. Quiet is not a good thing when it comes to a 5-year-old. Silence. She has fallen asleep. She needed that sleep because she was sick. Good. Wait a minute. I gotta go check to see if she's actually still alive because she is sick. All right, Mina's still alive. The stomach is moving in and out. She's breathing, sleeping. Great. All right. Here's what I'm going to do. I'm going to delete all of that, and I'll show you what you should have done. Okay, and if you've got a partner next to you that seems a little lost or needs some help, that's your job. Help them out, okay? Step 1 is we've got to add the horizontal arrangement underneath, okay? So that should be between the canvas and the camera button. Don't worry, as soon as you added that in, you're like, whoa, and the camera button moved down. Don't worry. Once we start adding buttons in there, it'll shrink down to the appropriate size and we'll be fine. Okay, so we've got our horizontal arrangement. In that, remember we have 2 buttons and a label, so we're going to add those now. So we're going to drag down and add a button that goes inside, and notice right away, oh, camera's back. Okay, I'm going to add the label in between. So there's the next is the label, and then I'm going to add the button. Okay, the next button. So I've got button 1, label 1, and button 2. You should have, of course, renamed these to logical names. Remember, it's really important in programming to give these all your components logical names so that we can, 1, know what it does, and 2, know what it does. So our first button is the minus button, so we can give it a simple name of minus button. Such a brilliant name. I, of course, clicked on the plus button. Ah, Montague. All right, so here we go. Let's rename that. That should be plus button. Okay, so that's plus button. Your first button, button 1, should be renamed as minus button. Okay, and inside label 1, even though it's a label, we still have to label it so that when we get to the block side of our programming, we know what component to select. So we're going to rename this. What is it showing? It's showing us the size of the dot in text. So let's just call this simply dot size label. Okay, if you named it, oops, I put a slash in there by accident. If you named it something along that line, great. As long as you can tell from looking at the name, it's dot size label. Okay, so we've added the components, we've renamed them to logical names, and now we got to worry about the properties over here. So we're going to move our way across. First step you should have, don't forget, change the width of that horizontal arrangement to fill parent. Okay, so it should be fill parent and OK. Okay, remember, this is an example of abstraction. Why? Well, it's an example of abstraction. I don't care the size of the tablet now. Okay, our fill parent means is as the button fills across, if I move it this way, it'll adjust itself and fill up my screen. If I put a specific number, if I put the height in there, when I went into my height or width property, if I went in there and I typed in a certain pixel number, that's fixed. That won't change. That means if I rotate my app, doesn't matter if I'm this way or this way, the app or the button is going to be the exact same size. Ooh, you can see a reflection of the app through the screen. Interesting. Okay, so that's an example of abstraction. We've taken out the specific number. We've abstracted out that specific number. We don't care what the specific number is, the screen size is. We just care that it fills the screen. It fills the parent. Okay? And so now our app, it doesn't matter if we put it on a Galaxy Note or a small little Google device that's really small handheld. Whatever the app is or whatever the device is, this will always fill the screen. Okay? So that's an example, another example of abstraction. We think about just the big idea. Fill the screen. What size? I don't care. Just fill it up. Okay, so that's what we did by clicking on fill parent. And we need to do that for not only the horizontal arrangement, but we need to do that for the 3 things inside there. So you should click on the minus button, fill parent, dot size, fill parent, and the second button, the plus button, fill parent, width, fill parent. So now, not only will the horizontal line fill, or the horizontal arrangement fill the canvas, those 3 components inside of it will fill its parent, which is the horizontal arrangement. Now, of course, we need to fix the text for the minus button. So the minus button text property should just simply delete that and change it to the minus button. Okay. And for the plus button, just click on the plus button and change its text to plus. And for the label inside here, when the app first starts, we should have it display the original dot size, or our starting dot size. So we're just going to simply type in with a capital D. Remember, punctuation still matters. Dot size equals 5 with the correct spaces. Okay, and then we have it there. And just from experience, I can see that this doesn't look too great. One, the main reason is that everything here is like centered, and this text is left aligned. So it doesn't kind of match. It looks a little off. So just simply go down to your text alignment and make it centered. And the font is actually quite small when you run it. So change the font to 18. Gives it a little easier to read. So one more time, font size for the dot size label should be 18, 1-8. And the text should say dot size equals 5. All right, as you can see here. And of course, the first step you should do after you ever change the interface or change your programming is run the emulator. And hopefully you've done that before I did. So you won't have to waste time like I'm wasting time right now. But run it in the emulator and see if your app is updated. If you've done this already and you're waiting, click over to the block side and try to figure out how you're actually going to get this to work. How are you going to get the plus button to make the size of the dot bigger? So I'm just going to wait a second. I got 20 seconds. 19, 18, 17, 16, 15, 14, 13, 12. I'm faster. 11, 10, 9, 8. If your app isn't loading, as we know, it happens every now and then, you can reset the computer. As some of you noticed last week, or the beginning of this week, you noticed that App Inventor updated. They had a pretty big update where they brought back the backpack, and that's very similar for those of you freshmen. That's very similar to the backpack that was in Scratch Online, so you can copy and paste code between programs. And as well, they updated the emulator. So if you haven't updated your emulator this week, that could be an issue of why it's not working, because you haven't updated the emulator. Remember, sometimes when the emulator runs here, as you can see on the screen, sometimes a message comes up saying it's out of date, needs to update. You need to do that. And after you update, you need to reset the computer. So that could be a problem, JJ. Hopefully you got it working. All right. So here you can see the our emulator is working fine here, and the plus button, I have no idea if it's working. Well, obviously it's not because we haven't programmed, but the user interface, that's exactly what I want. I've got my button plus, button minus, and in the middle, by the end of this lesson, as I click on these buttons, this here should update with the correct information. Okay. Wipe still works. Camera, can't test it on this, but it should work. Okay. And we've got our buttons working up here. So our next step, let's just move that off to the side, is we have to start programming with blocks. The basic idea here is this. We have a program where we have a new button. I click on that button, okay? I click on that button, the dot size goes up by 1, okay? Sign language. Brr, brr. Okay, it goes up by 1. We got to think of the big problem, okay, which is button is clicked. We're going to change the size of my dot to go up 1 number. When the button is clicked, we're going to change the size of the dot to go down by 1 number, right? Because we've got 2 events. We've got the minus button and we've got the plus button. And in between, it says the name of or the value of the dot. Okay, so how are we going to do this? Well, with what you know right now, you can't. You can't. You haven't learned everything yet. We're only beginners. And we have to use a block that starts with a V. Go ahead and look in your block palette. Look in your palette in there, the built-in blocks. Which one starts with a V? That's right, Ellie. Variables. Okay, we got to use a variable for this. I'll explain how variables work. You freshmen will have a leg up because you all know how variables work. You worked with variables last year with Scratch. That's why I made you do it, so that this year when you have it, you're one step ahead. Okay? So we're going to use variables for this. Let's go over to the screencast. Okay? And in our blocks, we've got variables. There's not a lot of blocks here to deal with. Okay? What we're going to do is we'll build this, and then I'll come back and explain variables in detail after. Okay, so the first thing we got to drag out is initialize global variable. This is how we create one. Okay, with our variables, this is how you name it. Okay, where it says name. Just like our components, we have to give them logical names so that when other people look at our programs, as well as yourself, when you come back and look at this program 6 years from now, you should be able to look at your code and clearly understand what happens with just looking at your code. So if you give these weird names, like if you just called this variable, pizza, what are we talking about? Our program has nothing to do with pizza. Why are you calling it pizza? Okay, you could call it pizza, but it doesn't make any sense. Okay, so you got to give them logical names. So this variable that we're dealing with here is dealing with dot size. Okay, it's the actual size of the dot on the canvas, right? So let's just call it dot size. Done. Type it in, dot size. Now, clearly looking at this, you can see that we have a variable called dot size. You can tell just by looking at the name what this concept is dealing with. Okay, so we've got to initialize. That's another English word for create. And as you move your mouse over, what does it say? It says creates a global variable and gives it a value of the attached blocks. So we're going to attach a block in there to give dot size a value. So this is basically creating something called dot size, and it's got a value. Okay, our value is coming from math class. So go over to the math blocks and just drag over that first empty block. We used this block before. We used it down here for the radius. Okay, and what is our radius? It's 5. Okay, so our initial dot size is 5. This should make some sense to you, right? So when the app starts, the app in the background is going to create a variable called dot size, and it's going to give it a value of 8. We haven't used this variable yet, but it's created. We've got a thing in our program called dot size. We've got a variable. In a few minutes, I'm going to explain what that thing is, what a variable is. Okay? Now, we've got an event. What is the event? Eric, what's the event? Come on now. What? Can't hear you. What? Sorry. The event is a button click event, right? Try to translate this code. Try to do it on your own now. Translate this idea of when the plus button is clicked. We'll do the plus button first. Okay? When the plus button is clicked, change the dot size to whatever the dot size is now, plus 1. Right? That's that idea. Remember I mentioned. Take the dot size and up it by 1. Okay? So take that event, put in an event when the plus button is clicked, when someone clicks on the plus button. That's the event. Once that event happens, what does it do? Change the dot size, which is a variable, change dot size to a new value. What is that new value? That new value is whatever the dot size is now, plus 1. Right? So right now it's 5. If I hit the button, it becomes 5 plus 1, 6. I hit it again, it becomes 6 plus 1, 7. Okay? Spend a moment now and program that. I'm going to get some more water, and when I come back, Eric should have explained to all of you how it's done. I'll give you another 30 seconds. Okay, I lied. I gave you 40 seconds. All right. What did we do? As I mentioned, okay, part of programming is taking this English words that I throw out of my mouth, or the English that you read on a paper, translating that regular everyday English into a program, into a problem. Okay, or I should say a solution. Take the problem, turn it into a solution. And I mentioned, make an event that when the button is clicked, we are changing the value of the variable by 1. Okay, so that is a plus button event. So we grab the plus button, right? So when the plus button is clicked, do something. What are we doing? We're changing the value of the dot size. So we click on variable, and not creating a new variable, we're going to start using these guys. Okay, we got a getter block. Yes, that's what it's called, getter block, and a setter block. We're not getting a value, we're setting a value. Okay, as you can see, the little help box says sets the variable to be equal to the input. Huh? Well, what that does, you put that in there, set. Okay, set what? Well, from this drop-down list, you can choose the variables that are available. We only have one variable, so there was only one option here. But you can have as many variables as you want, right? We can have more variables, and from the drop-down list, you can choose here any variables that are available. Okay, right now we only have one, so it's not a big deal. So set the global dot size. So this means set, that means change. The basic way of saying change this variable to something new. What are we changing it to? As I mentioned, it's math. Okay, something plus 1. If we look through our list of all the math that we can do here, oh, look at that. Yes, you can even find sine and cosine and tangent. What? You mean you can make a program that will do your trig for you? Yes. Yes, you can. Square root? Yes. Can you make a calculator? Of course you can. Okay? We're just going to be simply doing plus. Okay? We're going to drag that button out. So now we got set the global value dot size. So change its variable to be something plus something. Well, we know what the second something is. Did I just say the bad word? I said something. I said a thing. Sorry. We know what the second value is. The second value is 1, right? It's whatever is in here, whatever is the dot size plus 1 more. What it goes in here? Well, the dot size. So that's where we start using get. Get what? Get the global dot size. It's this simple. Okay? When the button is clicked, this is our event. When the button is clicked, so this is the result of our abstraction. We figured out that when the button is clicked, we set the global size to, global dot size, this is dot size, to whatever the value is now, plus 1 more. And hopefully my emulator is working so that as I click, I should get bigger dots. No, I'm not getting bigger dots. Oh my goodness, why is it not working? There is a problem with why it's not working. Yes, I know why it's not working. It's not a mistake, I know. I purposely didn't tell you. What's the problem? Think about it. We've changed the stuff up here. I said that bad word again. I said stuff. Oh, that's a bad word. Stuff doesn't mean anything. I've changed our variable. I've created the variable. I should say we've created a variable. We've created an event that allows us to change the value of the variable. But are we actually using the variable? No. We haven't used the value yet. We've changed it, but we haven't applied it anywhere. We haven't put it into our touched canvas. We've got to take this fixed number of 5 and throw it away. And what do we got to put in there? We've got to put in the global dot size. Okay? Now it'll work. Now when I push plus, I get a bigger dot. Oh my goodness. And is this an issue of eventually if I keep pushing this? Yeah, I know the whole room is probably filled with a million clicks right now. How big can I make it? Eventually, yeah, you're gonna have like a huge button or a huge dot, and you're just gonna click once and it's gonna cover the whole screen. Is this a good thing? No, it's an error, right? It's an actual bug that we have to fix later. But very quickly, we filled our whole screen up with a color. Okay? But this is a perfect, amazing example of abstraction. Okay? We have taken the idea that we have a dot size of 5, a specific number, which is really limited, right? It's a finite, fixed thing. I don't want that fixed idea. I want my program to be general. I want it to be any dot size. I don't care what the dot size is as long as it draws a dot. The user can figure out what dot size they want. Okay, so how did I do that? I created a program where the user can add a button, or sorry, add a value to that. And if I look in my program here, the radius, my radius doesn't care what size the dot is. Okay, it's just going to get that value from up here. Okay, it's very general. Okay, so we've taken a program that has a fixed dot size, abstracted out that really small detail, and made our program more abstract. It deals with a general number now. Okay, this is a good thing. So what we're going to do now is we got to do this for the minus button, which I'm sure most of you have done already. So you right click on what you've done for the plus and you copy it. I'm going to stick it underneath here. Okay, and you just change that to minus button. We're still dealing with global dot size. However, we're not dealing with the same math. We're not dealing with +1. We're dealing with -1, right? So I'm going to get rid of that block and from the math, and I'm going to grab its buddy, the minus, and we're going to go something -1. It's going to be the same code, virtually the same code, except now we're just dealing with plus and minus. Do we need to change down here in the radius? No, of course not, because it doesn't matter what the number is, big or small. This guy will just use it. Okay, so if I go back and check my app now, I still have that big dot, and if I click minus, I click red, change color, you can see, oh yeah, the dot size is small. It's getting smaller, it's getting smaller, getting smaller. Yep, great. It takes a lot. Wow, I clicked it a lot. All right, so yeah, you can see I'm getting smaller and smaller numbers or colors now. So my dots are getting better. Okay, done. So we've added some great user interface part now, where the user themselves are dealing with the size of the dot. So just like we abstracted out the fixed size of our buttons, we've abstracted out the fixed size of our dot size. We don't care what the dot size is anymore. The program will update and draw with whatever dot size the user cares about. All we as programmers have to do is just worry that we've had the code that allows us to do that. Okay, so down here, when we're using the global variable doesn't really care what size it is as long as it has a number. Okay, so now we got to get back to this idea of variables. What is a variable? Do you remember from freshmen? Do you remember from your days of Scratch? Okay, pretty much. I think in Scratch, the variables were found in the data section. Let me just load up Scratch here on the screen for you. Okay, yeah, the data. We had to make a variable. It was also orange. Okay, what are the dot size? Okay, pretty much the exact same thing. Done. Dot size. Great. Same concept. Same colors even. So we have an initial dot size of 5. What does that mean to the computer? Okay, we have to come up with the definition of a variable. And so now you're realizing, yeah, your math teacher wasn't lying to you when they said you're going to use math in all your subjects, not just math class. You're going to have to use it in computers too. All right, so the easiest way to describe what a variable is with this, a Tupperware container. You may be laughing now, but it'll all make sense shortly. Okay, so a variable in computers is similar to what you've learned in math class, but different. Same, but different. Okay. In computers, what actually happens is that when you create a variable, okay, and you've learned some of this stuff, some of the hardware stuff involved, so it should make a little more sense. What you've actually done when you create a variable, you've literally told the computer, and remember your smartphone is a computer, you've told the computer, go into RAM, go into memory, and make a certain section of memory that variable. You've literally told it, hey, go into RAM, I want you to take a section of RAM, right? Here's our section of RAM, and I wanted you to give it a name. What name do we have? Dot size. Yeah, it's coming in backwards, I know, so that's, you know, it's a mirror, I know, but it says dot size. So we've got a variable called dot size. So this means that there's a section of RAM, okay? It's like a container that the phone or your computer has put a section called dot size. And whenever I mention in my program the word dot size, I'm referring to this container. So our first block that we made, the initialize global dot size variable, this block here, okay? This block here, this initial global variable, okay? This is literally creating this green Tupperware, and I've given it a title, okay? When we put the value of 5, we've literally told the computer that we have an integer, int, that's short for integer. We've said, go into that container, put in an integer of 5. Whenever I say the word dot size in my program, that refers to go into this box and get me what's inside the box. Our first line of code said, create a global variable, a global box, global meaning anyone in the program can access it, create it, call it dot size, and put a value of 5 inside. Then we changed our program, and what we changed it to be, every time someone clicks on a plus button, I want you to add 1 to that. So that means go into the variable, go into the box, and I want you to find whatever value's in there, that integer value, okay, find that value, and I just want you to add 1 to it. Done. So now this variable is now not holding the value of 5, it's holding 5 plus 1, okay? And then the person hits plus again. Whoop, dropped it. I dropped my plus. Okay, they hit plus again. So we've got a plus 1, another plus 1. Can you see that? Plus 1. And that means go into the variable, plus 1. So now inside here, I have the original 5, plus 1, plus another 1. So I've got 7. Forgot how to count for a second. So every time you're clicking on the button, the code that you've just made is telling it to do exactly this. It's literally telling it, hey, when you start the app, okay, and that's what happens when the app starts. When the app starts, it automatically makes this variable. So as soon as you push power on the app, as soon as the emulator starts, it makes this variable. It makes initial dot size and puts in a value of 5. It's making that box and putting in 5. And then every time the user clicks on a button, it's either adding a value to that box or taking a value out of that box. The box doesn't change in terms of the actual physical box. There's always a box there, okay? Dot size is not going away. What's inside doc size can change. That's what a variable is. A variable is a named location inside the computer's memory in RAM. Okay? So it's literally giving a name to a section inside RAM. So you could think of RAM really as a whole bunch of these boxes. Some of them have names, some of them don't. Okay? We've given ours a name of dot size. Okay? And basically the computer just says anytime it sees the word dot size, it just knows it's talking about this box. This is our variable. Okay? That's what a variable is to computers in its most general, simplest sense. Okay, so it's similar to math class, right? Because X, Y, Z is holding a value, okay? But it's a little different than math, and we'll see a little while later, especially if you take AP computers, how it's a little different because usually the value of a variable is usually set and it usually stays the same. Okay, whereas a value for a variable in computers is always changing. The variable doesn't change. What's going inside it changes. Okay, so we've got this idea of variables now. Yeah, and we've got, what, 22 minutes left of class. So I think we need a brain break. So here's what you're going to do. You're going to stand up. You're going to walk around the classroom, and when I say stop, you're going to find the closest person to you, and you're going to answer the question that I ask. So do that now. Stand up. Push your chair in so we don't bump into anything. And begin to walk around the classroom. You can do it. While you're walking, I'll sing a song. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Hey, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Dancing through this... Dancing? There's no dancing in that song. I forgot the rest of the lyrics of that song. How about A, B, C, D, E, F, G, H, I, J, K, L, M, N. No, stop! Find the partner closest to you. If no one's missing today, there should be one group of 3. Okay, because we do have an odd number of people. Everyone should have a partner. Partner up. All right. Here's the question. And the person who is oldest goes first. Oldest person goes first. Here's your question. Good question. No. Here's your question. I want you to name the #1 place you would love to go on vacation. Like right now. If Miss Kim just suddenly gave you a plane ticket right now, she's like, bam, good job for being an awesome student. You're going on vacation. Where are you going to go? Okay, so think about that one place where you want to go on vacation. And 2, tell them why you want to go there. What would be so great about going there? Okay, so oldest person goes first, where you want to go, why, and go. Interesting, interesting. I want to go there too. If you haven't done yet, switch it up. All right, good job. Thank you for sharing. Give them a high five and say, I want to go there too. Done. Once you've done that, please return to your seats. Thank you. Where would I like to go on vacation? If Mrs. Kim gave me a piece of paper right now of vacation, where would I want to go? Strictly vacation, not to visit family. I would say I would love to go. Oh, that'd be easy. I really want to see the pyramids of Egypt. I would love to go to Egypt and just climb the pyramid. Even though you're not allowed, I would just be like, yeah, whatever, and I'd run all the way to the top. They can come get me. Yeah, I'd like to see the pyramids. That'd be cool. Go down the Nile, seeing King Tut's tomb. Do the whole. Yeah, I think that'd be cool. That's where I would go. All right. And what are we doing next? Oh, yes. We have a problem with our program so far. Yeah, we got to get back into it. I know. There's only 15 minutes left. You can do it. We've got this idea of we've got the buttons click, they change. That's great. That's awesome. Cool. We've got a better user interface in terms of usability. Great. Awesome. However, the number is not showing up here in our app. We can't get the actual number to appear where it's supposed to appear. It doesn't change. Even though the dot size is changing, the label is not reflecting the change. Okay? That's a problem. That's an error. Okay? That's a runtime error. Okay? The program's running and it's not doing what we want it to do. So we need to fix that. Okay? So let's think this through. What's our problem? Okay? Our problem is when the plus button is clicked, change the global dot size to whatever it is, +1. And we need to change something. We need to change another value. Another property needs to be changed. What needs to be changed? That's right. Whatever's inside our label needs to change. Okay? Right now, it's always going to say, for dot size, it's always going to say dot size equals 5. That's not fun. Dot size equals 5. I want it to say dot size equals 6, 5, 11, whatever we switch it to. Okay? I want that to be better. So, or sorry, not better. I want it to update real time. How do we do that? Think about what I'm saying. We want to change the value of the text inside the label. What do we want that text to be? And this is a really important part to figure out. We want it to be the text. So it should still say dot size, but it should also say 5 or 6 or 7. Okay? I'm going to give you 4 minutes to solve this problem. Don't be afraid to use the brain beside you. Try to solve it with your partner. At the end of the day, you can do it. How do we get the text to update and change inside the label? Change the label to be the appropriate text. One more time, here's the hint of the century. Change the label text to be the appropriate text. My cat just meowed. So 4 minutes. Oh, the cat meowed big time. Shh. Shh. Stop. Jeez. I'm just going to ignore the cat. If any of you have any questions, just ask Romario. Activate Windows now. No. I'm going to give you another minute. Was that Ilbun? Ilbun? 1 minute. All right, time is up. Up is the time. How did we do this? Well, again, think it through. We're still dealing with this one event. We don't have to create a new event, but we're adding to this event. When the plus button is clicked, change the global dot size. That makes sense to us. But we also need to change what's inside the label to reflect this change as well. So what are we dealing with? What component? We're dealing with the label. So we click the label, and as I said, we are changing the label's text. So you can click any one of these setter blocks. It doesn't matter. So I'm just going to click the first one, and we're going to click that setter block right underneath. And we're going to set the dot size label background color. No. We're just going to click from our drop-down list the properties we can change, and we're going to change the text. So set the dot size label text, and we're going to change it to 2 things. Okay? And that's why we're going to use this second block here. This allows us to have 2 different text show up. Okay? The first text is pretty simple. The first text is going to be the text that we have there now. That's never going to change. It's going to be dot size space equals space. And this is really important to put that extra space at the end, because if we don't, the number is going to look like it's right next to the equal sign, which doesn't look very nice for formatting. So you always have to worry about that kind of idea, that problem. So add the space. So we have dot size space equals space. Done. That text is never going to change. Then what do we add underneath? What goes here? It's going to say dot size, and then it's going to say the size of the dot. Well, where is the size of the dot? What is that value? It's not text. It's the variable, right? It's this variable dot size. So all we have to do is, well, we can just go up to get dot size. We can just get the value from dot size. Done. So whenever someone clicks the plus button, we're going to add 1 to whatever that is inside the variable now. Remember, the variable is the box holding a value. Then we're at the same time, well, then it'll look to us like it's at the same time, but then it goes in and it sets the dot size label, it sets the text inside of it to dot size equals global dot size. And let's see if my app is updated with that. Oh yes, you can see now I have got a dot size. It's going up. I haven't done the minus button yet, so the minus button isn't working. But the dot size, you can see as I click on it, okay, it changes. Notice I click the plus, and when I click the minus, it's still changing the dot size. It's just not showing up. And then when I click plus, it gets like a weird jump. That's because I haven't updated the size over here for minus. So let's do that now. Really simply, you don't have to write any more code. You just right-click the code that you've successfully made, duplicate it, drop it down into the minus button. And do we need to change anything? No, because it's abstract already. Dot size is never going to change. Global dot size, that's just going to change by itself. So already it's abstract. Done. And now if I go back to my app, the minus button is updated as well. So now I've got a minus button and it shows up inside the app. Got a plus button, it shows up inside the app. I can see how it changes in real time. And I've got this wonderfully working app. All right. The last part, and we're not going to do this today. You're going to have to think about it because class is almost done. Yes, take a glance at that clock. Okay, we have an error in our program. If I keep clicking minus, 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 oh my goodness, what happens? I get to like minus 14. How can you have like a minus size of a color? That means the canvas owes you pixels. Give me back pixels, right? And even if we get up to 0, how can you have 0 pixels? You can't. We need to fix this bug, and this is an official bug in our program where when I keep clicking, I can just keep minus. What? I can draw my line. This is a line because I haven't touched any of my line programming. We're just dealing with dots. But I get a minus number. This is a bug. How do you fix this bug? Okay, that's what you got to think about, and that's what we're going to solve tomorrow. How do you stop this? And the solution lies in the first thing we reviewed today. If you remember, what is the first thing we reviewed today? If something happens, do this. You're going to have to use a decision structure to solve this problem. All right, class is finishing up. You've done a lot today. Once again, I want to thank you, and I want to thank Miss Kim, and he's not here, and I want to thank Mr. Edward for helping me out today, helping you guys, helping me out, take care of Mina. Thanking you all for being understanding of how we did this. I hope it was a little fun and interesting. I certainly learned a lot how to do this. And tomorrow, if you have any questions related to this, ask me by all means. We'll go over this again tomorrow. Eric, I'm not forgetting. You're gonna have to talk to me. What are the examples of? Remember, I asked for an example of if then. Okay. So thank you again. I hope you have a wonderful afternoon filled with pizza, and more pizza. Maybe a little bit of homework, but lots of pizza. And don't forget to log out of your account. Don't forget to turn off your computer 100%. Please turn off my computer so we don't waste energy. Turn off the lights, turn off the air conditioner if it's on, and turn off the projector. And thank you for all of that. Thank you for understanding. I'll see you tomorrow. And thanks for this. Hope you have a good day. Don't be late for the bus. And have a good one. I hope you, I really do hope that abstraction made a little more sense today. Okay? All right. Have a good night. I'm going to turn this off now.